All right. Thanks again for staying back. It's been 2 fun days at RootConf, and I'm sure you've heard Kashif, Swapnil, and Devi delivered various presentations. So this is the last session for today, and it's more of a chat regarding how to scale infrastructure, right? And as you guys would have heard, folks here have had different experiences scaling their respective infrastructure in their firms. So what we would like to probably start with is, I know, I'll start with Swapnil. So when we talk about scaling, right, and it's again buzzword like all the other things that go on in the industry. What does scaling mean to you, or what would you define scaling as?
Yep. So when we talk about, so I will just start describing about what used to happen like 3 years, 4 years back, and what happens now as well. What happens now as well? Like if we have a Hadoop cluster, right? We talk about scalability. We talk about adding nodes to it. But mind you, that is a manual intervention. When exactly is your whole application going to ask for more nodes? It cannot be controlled from outside. Your system should have the capability of scaling at the runtime, perform the process, and just go away. So it should descale as well. Scalability, if scalability talks about adding it, it should talk about removing it as well. And not just that, I think till when we talk about the horizontal scalability thing, so there are two kinds of resources. One is the compute resources, and the other is the storage resources. If we want scalability at the storage level, we should not pay for the compute resources. So again, a decoupling is required from that side, and because of the same things, that serverless infrastructure and everything is coming into picture these days.
Yeah. By the way, guys, if anybody has questions, we'd be more than happy to probably entertain them. I don't know, raise a hand. We make sure that the mic reaches through. Yep.
Hey, Swapna, got a question for you. So when using DCO, say a big data company is trying to look into containers, right? Okay, can you hear me now?
Yeah.
Okay, so if a big data company is trying to go into containers for the first time, and if you had the option between Mesos launching a Docker container, but then you also have the option of some of the non-big data applications like Nginx, Node.js, and things like that. So what are some of the advantages of launching these non-big data applications via Docker, Kubernetes, and DCOS rather than just going with Mesos and Docker?
So just let me know if I understood you correctly. So you're asking about what we have to do if we want to have, if we don't want to use DCOS, Kubernetes and all, right? Or do you want to?
So yeah, so not use a Kubernetes and just launch those non-big data applications as well with Mesos and then Docker that way. Like, why would we want to add an additional layer of a Kubernetes in between? Like, what advantages does that give us?
Yeah. So I will just start with an analogy. So during the talk I took an analogy of the operating system running on my machine, right? So the DCOS is the OS which is on my machine. Now on my machine, it can be a case that I have multiple different browsers, right? So I can have Chrome and Mozilla both, right? And it depends on us what to use. Now Kubernetes and Marathon are more or less that thing, right? So either you can use the orchestration engine as Kubernetes, or you can use the orchestration engine as Marathon. The days are kind of gone when you have like one machine which is being kind of created looking at the peak load, right? What will happen during the non-peak load? And why this situation has arrived where we are kind of squeezing everything out of it, because now is the time when we are producing a huge amount of data, right? So now the adverse effects of underutilized infrastructure is kind of more dominant now. So it again depends, like the use case which I shared, we were using Kubernetes and we have full plan of actually bringing our, basically reusing our work there. But right now for the time being we are kind of running, I was showing all the demos on Marathon, just for the sake of simplicity and not adding complexity.
So here's another question, right? So when you talk about using all of these tool chains, which is one very different story, but if you look at any company which has growing pains when they start scaling, when the business starts booming and it comes in, a lot of times it turns out that the architecture you guys like the architecture a company envisions to begin with may or may not scale, right? After a certain point in time, you start hitting a wall. And how to tackle those problems? Have you like would you guys share experiences on that? How to tackle those issues? How to when you say, hey, this is we are designing something, but we are going to hit a wall at some level. Can you predict that? Can you forecast that? Would you guys like to share experience?
I'm not clear what specifically you want me to answer.
So when you go ahead and you say that you start scaling infrastructure, right? You always have a certain scale in mind. As and when the company grows, more and more user comes in, more and more traffic comes in, or the equivalent events happen. You're going to run into a wall at some point in time. Is it possible to kind of predict it? So one thing is that you use tool chains to scale, which is the tech part of it. But how do you kind of take other non-technical factors into consideration? For example, cost for scaling, right? Or where do you start planning for scale? Do you start only when the deployment happens? You start it right when the coding happens? Where do we start? Like for example, if somebody is there whose company and business is scaling, what are the points they need to keep in mind?
So I don't think I have a good answer actually. What I do is I try to use elasticity as the driving principle behind any design, whether it is architectural or technical, or whether it's organizational design. And the idea there is that systems should be able to scale on their own, and I try to design for that. And the way I do that with technology is distributed systems, and the way that I'm currently experimenting doing that with organizational design is using a system that Spotify invented. It's their agile practices. But I think the key point there is elasticity. You can't predict when things will happen and what will happen. You have to be prepared for quick and nimble changes and build strengths for quickness of change, basically.
So
just to add to what he said, so that elasticity or and decoupling of things should be handled from the ground, from the servers or the APIs or microservices or the application that it handles the requests, etc., and the database that you use. Everything should be chosen or to be designed in such a way that you can replicate each one of them, or you can scale at each one of them, so that when that big time comes, you won't lose it or.
So I want to discuss about actually what is scalability that we're talking about. I think the different interpretation of scalability I see here. Okay, so one thing that was mentioned is scalability, auto scaling capability of the infrastructure. Okay, I don't really see scalability as something that's only specific to infrastructure auto scalability issue. I mean, I see scalability. I'll mostly look in terms of a property of the application. Can it linearly grow? Given enough resources, whether your resources grow automatically or you manually do it, it's a secondary issue. But I see scalability more as it's a behavior of an application. Does that application has a capability to grow, take that load given enough resources, right? I mean, I don't know if that's the right interpretation. I want kind of your inputs on that. Sorry.
Yep. So I agree with your point. So you are talking about the technology thing. So anyways, if you see any of the technologies we are talking today, the processing time is kind of function of the infrastructure right now. So the data, earlier we used to hear about that the data has grown, so it is taking more time and those kind of things. Of course, the parallelism, distributed computing and all things will be there. Along with that, we need to have the capability in terms of your system scaling up so that the SLA, they can meet the SLA. We should not have we can talk about maybe, let's say I have an application which requires 100 threads right now, and in the future it requires 200 threads. So we should have the capability of actually giving my application 200 threads in one go. Otherwise, my 100 threads will be kind of waiting, and it's kind of one-to-one scenario. So it's, I think as you rightly said, it's more on the it includes the application side as well as how it happens on the infrastructure side as well, how it scales up.
Yeah, the way I think about this is, I say, what will happen if you don't scale? What is the property the universe will exhibit, right? And essentially, if you don't scale, you are not able to service a customer, right? That's the net problem. So there are three things that kind of drive that. There are three levers to that. One is the organization, right? Sometimes your organization cannot scale simply because it has, say, one example is it doesn't have a feedback loop with the customer, is not able to understand. So that's the organizational aspect. The second is architecture. You cannot simply scale because you've architected it wrong for whatever reasons. And the third is indeed application design, which is also what you're talking about, which is what choices have you made when you design the application. For example, concurrency model, right? So a certain concurrency model will do well in some cases and certain concurrency model will do well in different cases. So yes, indeed, I agree with you. There are all of these aspects to scaling. But in the end, the effect is the same. If you miss on any of them, you won't be able to service customers, growing customers. Yeah. Yeah. So architecture doesn't have only auto scaling. That's indeed true. Architectures have been scalable for a while. We've been skinning the cat in different clothes all this time, in a way. But there are other aspects to architecture apart from just the ability to add machines, right? For example, the difference between a monolith, which say is stateful, and say service-oriented architecture, which has a bunch of stateless services, is a function of architecture, but not a function of the number of machines you can add. So that is also there. Absolutely, I agree with you.
So here's one thing, right? That when we talk about design for scaling, right, we usually think in technical terms a lot. But what about the non-technical aspects? For example, cost. So when we scale, you guys can also talk about how do you factor in cost of scaling as well. Like elasticity, yes, it's a good thing. But if elasticity, let's say it is unlimited elasticity, it's going to come at a cost. So where is it that you start? Like Devi said, you start right from the ground up, but it is not always the case in real life, right? That's the ideal scenario. It doesn't always exist. So there are trade-offs that are usually made. So you guys have your own experiences on it? Like where you guys like probably designed something and or maybe took a system that was not designed very well and tried to scale it. And
I'm sure all of us have taken systems and tried to scale systems which aren't designed for scale. I don't really know how to answer this in terms of cost. Okay, because the way I've looked at this and the thing that I advocate people doing. So what happens, if a system you made is very expensive to run, you rewrite that system, right? That's what happens in reality. Now, but how do you think about this in terms of cost? All I do really is put in I try to drive a metric or awareness of a metric, which is what is the cost of the core service rendered to the client, right? So now I'm going to be working with, say, Shuttle, which is an Uber for buses. And there, let's say, a booking or a ride that a person is taking. So the metric that we drive is what is the cost per ride, right? And before we start architecting a system, we say if we want to go to 100,000 rides, our cost per ride must be so much. And then we use that as a barometer to continuously course correct. I have not been smart enough to kind of do more than that for cost, so I can't.
so
Actually have a follow-up on that. So we are kind of in the same boat, cost and analysis, like, how much cost do we put in the cloud versus, so we look at cost two ways, right? So one cost is, of course, the money, but we also look at the cost of the engineers and like how much effort it puts on engineers to like get some of that happen. So obviously, auto scaling, we can do on-prem and, on AWS as well. But implementing something like that, internally on-prem is much more, difficult with a small team. So at that point, the cost of AWS might offset the cost of the person or the engineer spending that time, like, and oftentimes I see, engineers or like the developers are always, more in number than the folks, the operations who actually do the work. So a lot of times we take the human cost or the engineer cost into consideration as well and see what,
Yep, I completely agree with you. I mean, even whatever, so it's just not the infrastructure cost and the cost which kind of we can see upfront. It's how much effort, how many tickets are coming up, the DevOps kind of contributing for that. Of course, everything kind of cumulative will decide upon. Agree.
Yep. Thanks for that. So there is the aspect of cost that we've covered, right? There's also the aspect of technical tools that we have covered as well. And like Devi said, okay, we start as close to the ground up as you can, wherever you can. So do you guys have had any experiences on legacies, scaling legacy systems you probably would have inherited, right? They are running on a given scale, and then all of a sudden the demand increases and you're like, okay, this now needs to go up. So any challenges you would want to talk about on that front as well?
Okay. So in my experience, I mean, I had worked in like couple of projects who are kind of replacement for the legacy systems. Reason being the data we talk about today. I mean, that scale of data was not present, and few years back, I think we could have talked about scaling your legacy system, maybe improving code, maybe improving a better hardware, I mean using a better hardware, this and that. But right now, the amount of data we try to process and the amount of data we are aiming for, let's say by 2025, I mean, there would be a huge, I mean, it would be either impossible to scale it kind of, and if it is possible, we would be compromising at some other place. So that's my assumption. However, I had worked on personally on a couple of projects which were kind of match the numbers with the legacy numbers, because those were the ones in the production. If they match, we'll have your system kind of. So yeah.
Any questions from the audience so far? Please feel free to ask. So when you talk about, I know you also mentioned initially, right, that when you are making a technical choice, you have to be very cognizant of what is it that you're paying for. If you want compute or you want storage, right? And any pointers on how to really make that choice? Like initially, like you do prototyping, you do like phase rollouts. How do you even arrive at how do you test for it? How do you figure out whether it is going to be compute intensive or IO intensive?
So a couple of things that we look for, right? I think the first thing that you look for is whether this thing has the features that we need. That's one check. Second, you look for what kind of documentation is available on that project. What is the maintenance of that project? These things matter because when you are in a lurch, you will have nowhere to look. Third, you look for if there are companies that offer services on that product. That's usually a good sign. That means it's a tenable product. People have been able to sell it, and that will probably scale. Then lastly, you see what is the delta, or I see rather, what is the delta from your current current tooling to that tool. Sometimes a tool is so different from what you're using that when you change that, you have to change other systems which are adjacent to it. And so sometimes you might pick up something which is less advanced so that the change does not ripple across. And then once that's stabilized, maybe you can do a second change to move to the end state. So these are 3 or 4 things to look at.
Hi, can you just explain something on the stateless versus stateful architecture practices, like when you grow the big data application around it? Can you talk something about it based on your own experience?
Can you please repeat?
Okay, my question is out of your own experience, like building large scale distributed systems, can you talk something on stateless versus stateful applications, like growing cloud native applications? Like how should we build our architecture around these practices?
So to kind of rephrase it, like your experiences with stateful services and stateless services when it comes to scaling, because they're both very different areas of scaling. Did I get that right?
So ideally you want stateless services, but obviously the whole world can't be stateless. It will become very difficult to be useful. But yeah, stateless services are easier to scale because simply they don't have to coordinate or wait on resources. So that coordination, the cost of coordination doesn't exist. So you want to defer to that. Whenever possible, make a service stateless. When you have to make it stateful, my thought process is usually that you see what portion of it needs to be stateful. Sometimes just a small portion needs to be stateful, and then you try to move that out. So as little state is usually good. One way of reducing state is transferring state to the client. So making it the problem of the client. It doesn't always apply. It's not always a good idea. But sometimes, you say, okay, I can't make this stateless. Well, can I send the state to somebody else? Can I make it someone else's problem? If you can do that, that's usually a good solution. So I try to reach stateless services, but it's not always possible.
Yeah, I completely agree. I mean, the aim is to be stateless, but there are few situations where you just cannot be stateless. So like one scenario can be, let's say that your system is ingesting a lot of amount of data, and you just cannot remove the possibility of one of your components not failing, right? So you need to have that failover kind of a thing, because with the growing data, with growing factors, still you want to meet the same SLA, right? So you need to have that. I mean, big data applications, if you talk about as a Spark or Hadoop, or for that matter data flow for GCP, they talk about why they are good is because they basically they can restart from exactly the place from where they failed. So yeah, but ideally speaking, yes, stateless is fast and I mean easy to handle, and yeah.
So when you talk about different services, right? One of the key aspects is when a lot of services, the microservices kind of an architecture come and start working together, right? So do you guys have any pointers or thoughts on how do you scale an entire ecosystem of services that works together to meet an increasing demand? For me, what may happen is you have a single entry point to your system, and then the service fans out, the request fans out to multiple services, and each of those services have their own different performance measurements, their own SLAs to their upstream and downstream. So any thoughts on how to scaling or designing for infrastructure for those services as well, where you say, okay, I'm allocating resources for one given service, but if they're not used, they can be taken up by somebody else who needs them.
So so when you have just one application running on a system and you talk about scaling, you are kind of doing vertical scaling, right? And if your application is having vertical scaling, it is going to hit a roadblock. For example, if you are using Google Cloud Platform, the maximum vCPUs you can assign to a particular VM is 64. If your requirement goes above that, it's not possible, right? So you will be able to, if vertical scaling cannot be an option for a data intensive application, right? Compute intensive, and for the rest of the things, we can say that, like, I mean, it is going to hit a roadblock. And looking at this only, I think with Amazon you get something like Lambda, or for that matter Google Cloud Platform you get Google App Engine, where if you are using low amount of resources, it charges you for that, and the moment you increase the size, it will increase to infinite resources, and it will charge you that much amount of time. So I think and they behind the scenes actually use containerization. So yeah, we have like Kubernetes and all, which does the containerization, but still not up to the level what Google has behind the scenes, to be frank. Google has just given a small subset of functionality of their big containerization orchestration manager, which is Borg, which is Kubernetes, and the whole world is talking about it. So they have that. I mean, they had done it. How they are doing it is once they come out. But right now, if you talk about, if you have just one system and you intend to do it, to scale it vertically, it is going to hit the block once your resources are kind of consumed.
I think the question was, how do you scale a bunch of services together, right? And The way I look at it is with monoliths, you had like a single point of entry, and so you had to scale the whole monolith, and you couldn't, your one bottleneck at the top of the monolith would kind of affect quality of service to the rest of the monolith code flow. And then when you broke it down into services, you were able to kind of tackle that separately. And I think what you can do with microservices and scaling a bunch of services is make them distributed. So actually not have one API gateway for your client, but have multiple API gateways and have them delivered directly to the client. And where possible, use peer-to-peer chatter as opposed to orchestrated through some kind of a master slaves or, some kind of a semi-distributed centralized architecture. So it's better to have peer-to-peer and to have multiple gateways and not one gateway.
All right. We take like 2 final questions from the audience if you guys have any. Quick one. We were drawing to a close and we actually overrunning the schedule time.
Hi Devi, I've got a question for you, but it's more specific than the other questions we've been tackling so far, around scale and all. So I want to ask you, during your talk you spoke about how you sync the data from Postgres to your ES cluster, and you had a job which ran every minute to do it. So what I would like to ask is that, do you sync your entire data set to ES every minute, or do you have a way of finding out what incremental changes have taken place, and those are the ones that you pick up to reindex to the cluster?
Yeah, could be a little more clear. It's a little hoarse.
All right, sorry. So what I was asking was that you spoke about a job that you run every minute to index data from your Postgres to ES cluster, and it ran every minute. So my question is that, do you sync the entire data set every minute, or do you have a way of finding just the incremental changes that have taken place and you just sync that much data?
So that 1 minute has come from the business, not from the technical side of it. So as I was saying, the Postgres is our primary data store, and our clients or the talent, the candidates who are searching for jobs, they don't see a lag if it is just 1 minute or below 1 minute actually. And that's the reason we just said, okay, 1 minute is fine for our requirements, and we don't need real time, exactly real time, as in when the candidate changes her profile on Postgres, which goes to Postgres. It doesn't need to be synced into Elasticsearch in real time and got back into the search results. So we were good at that. But if you had real time needs for your application where you need to sync to or fro to Elasticsearch, then as I was saying in the last slide, you should try the bulk APIs and see how much your cluster can take in for indexing, and then double it, keep on doubling it, and find the right optimal size of your batch, how much you can ingest into it. So that should decide the time limit. Let's say if your Elastic cluster can take n number of thousands a second, then how much is your application pushing to Elasticsearch, and how quickly you reach that n number of thousands which needs to be pushed to Elasticsearch. So that should drive the time limit. Yeah. So technically, Elasticsearch can index more than not just tens of thousands. It can ingest about a million records in bigger clusters. I have read use cases like that. So whether you need it or not is up to you. Whether you want to maintain that large clusters to ingest the data, do you have that much of data flow or not? It's the business needs should define it. Did I answer your question?
Yeah, unfortunately we are like overshooting on time. What I'd encourage folks is please sync up with the panel and the individual folks outside the hall. We are being ushered out, aren't we? Oh yeah, there's a time limit on the venue, so sorry. Yep, you can blame him. All right. Thanks a lot, everybody. Thanks for your patience again, and thanks to the panelists. I hope you guys had a fun 2 days at RootConf, and a very happy weekend to all of you.